This is Dylan Wilks, the CTO of Orange Photonics, and today we're going to talk about some of the converted cannabinoids, or hemp-derived cannabinoids. Lightlab has recently added a new module that includes testing some of these converted cannabinoids, so I thought I'd talk about some of the chemistry behind them today. I know there's a lot of talk about the science and efficacy, but we're going to focus really on what's going on in the molecules and why they are what they are. So to begin with, I'm actually going to start with hexahydrocannabinol, or HHC. And before I start drawing anything up here, I just want to, first of all, say sorry in advance for my terrible handwriting. But before we get into HHC itself and drawing out the nice big molecules, I'm going to just talk a little bit about what hydrogenation is, because that's an important function of HHC. It's actually a hydrogenated cannabinoid. So the whole thing starts with carbon atoms. So I'm going to draw a couple up here. And the reason that carbon is so important is it's the basis of all of our life, including plants and humans. So it's kind of a special molecule. And the reason it's special is it has 4 places where it can bond with other types of elements. In the case of organic molecules, like the ones in our body and the ones in cannabis plants, this is usually hydrogen or oxygen or a few other things. So let's just put a couple carbon molecules together here. What ends up happening when you have 2 of them is they actually make a bond together. So 2 of them are shared there. And I'm going to delete this. And then the other ones, usually in the simplest form, will have hydrogens attached to it. This is kind of one of the simplest hydrocarbons that you can make. And in the case of hydrogenation, what we're trying to do is add as many hydrogens as we can to this carbon molecule we've got here. And so what you do is you take a metal. This is actually a catalyst, meaning it helps the process go along, but it's not actually part of the chemical reaction. And this is something like nickel or palladium. The other thing you have to have is more hydrogens, because you want to add some more hydrogens here until the carbons can't take any more hydrogens. So we're going to have a bunch of hydrogens floating around. These could be bubbled through if you're imagining it in kind of an oil or a liquid. So you've got a bunch of hydrogens up here, and what will happen is these guys will say, hey, you know what? Let's not connect together. Let's grab a hydrogen on either end. And now what's happened is I'm going to delete some of these, or erase some of these so they're not in the way. Now what we've got is what's called a saturated hydrocarbon. So before we had an unsaturated hydrocarbon, now we have a saturated one. And the process of saturating a hydrocarbon is called hydrogenation. And they call that because we're adding hydrogens to the molecule. So this is actually what we're doing when we're taking a cannabinoid and making HHC out of it. So I'm going to go ahead and draw a HHC molecule on the board here, but I won't make you wait for it. So give me a second, and we'll come right back. Okay, we're back, and I've actually drawn CBN here, not HHC, because this is often the starting material for HHC. So just like we were talking about before, we're going to be trying to add a bunch of hydrogens to the CBN, which is the feedstock or starting material to make HHC. I won't go into the details of why CBN is a molecule of choice, but it's an easy one to start with. You can get purified forms and that kind of thing. So one thing I didn't note in my other drawing was that often in organic chemistry, they just draw these lines with little points in them. But each one of these points is really the carbons that we were talking about before. So if I were to just draw a couple in here, you can see what I mean. So those are those C's that I was showing before. Those are the carbons. And anywhere that they're not showing any lines coming up, that would be hydrogens. So what you see here is there's 2 connections, but really there would be a couple hydrogens here. And this is just a nomenclature of how people typically draw things. So I'm not going to draw it all like that because it makes a mess, which is exactly why people don't draw them in the first place. But just keep in mind that each one of these points is carbons, and they all have 4 little bonds somewhere. So when you see only 2, there's hydrogens hanging off the end there. And then, again, just like we showed before, there's these double bonds where these 2 carbons, these 2 carbons, these 2 carbons are all sharing 2 bonds instead of just 1. So now we're going to get into the hydrogenation. And so what we're going to do is, again, take a catalyst. Imagine you're bubbling hydrogen gas through here, so you have a bunch of hydrogens floating around. And what's going to happen is, just like we were showing in that simple molecule, all these are just the same exact thing is going to happen. Is we're going to get a bunch of hydrogens that are going to connect off all these different places. And what's going to happen is this double bond is going to go away. And all of the double bonds, once they're gone, is going to be what's called a hydrogenated cannabinoid, or hexahydrocannabinol is exactly what that is. So now we've turned CBN into HHC. And so that's really the process of what we're doing. Is essentially when it's being made, hydrogens bubble through, and all the double bonds are being filled with extra hydrogens. So we've got more hydrogens in HHC than you would have in CBN. And so that's where we go. That's how we got to there. I want to talk a little bit about why you might want to measure certain things within hexahydrocannabinol as well, since we do have this new module that can measure it. So one of the things that's really important is, since you're often starting with a feedstock like CBN, looking at process completion is really simple, because you can look at, hey, how much CBN do I have, and how much HHC do I have? Presumably, at the end of the day, if you've made a really good product, you've got almost no CBN, you've got almost all HHC. But if you had something wrong, like your catalyst isn't working well, or your hydrogen is impure, or something's going on, you're going to see a lot more CBN and a lot less HHC. Another thing is that this whole process isn't necessarily going to target just CBN. So if you have other cannabinoids, you could be potentially making some other partially hydrogenated cannabinoids, and those will show up as minor peaks. And what you're going to see ultimately is that you're going to start with 100% CBN, let's just call it, and you want to end up with 100% HHC. But what you're going to see is some loss of cannabinoids. So being able to measure both the purity of the original as well as the final product is really important. And so that's HHC in a nutshell. We'll go on to the next one, which is going to be THC acetate or THCO acetate in just a minute.